I have studied free energy now by training myself on various simulators for the past 5 years, training my mind to think like a simulator. There's not too much policy written into simulators. There is some, it can be picked out, and simulators are geared to the simulation of normal, conventional circuits obeying the laws of physics. The problem I have with the laws of physics is that, like any law, like any lawyer going into court, the first question a lawyer should be asking is, does the law have jurisdiction over my client? In other words, so what if he did something that nobody feels is justifiable to take license with? If the law does not have jurisdiction over his behavior when and where he did it, then the law does not apply, and thus no law was broken. It works that way with physics. Physics likes to be promoted as the body of laws that tells us free energy does not exist. And in a certain sense, that's true. I'm getting ahead of myself. But in a precise sense, it has no jurisdiction, it has no relevancy whatsoever, because free energy is not energy. That's the first problem we have. The colloquialism is invalid. Free energy is not energy, it's reactive power, and reactive power is not power. Reactance, electrical reactance, is a strange anomaly that we cannot prove its existence. We can model it using mathematics, but in order to do so, we have to use imaginary numbers, which themselves cannot be proven. Square root of -1 cannot be proven. But that's the only way to mathematically represent reactive power. And so free energy literally lives in a domain in which physics claims does not exist, and that's true. The sad fact is that's the body of the work of an electrical engineer who mans the computer station in charge of the electric grid. He's got to balance the load, as they call it, and much of the load is reactive power. There could be more reactive power than what is normally there because they're not geared for free energy, but they do have to deal with it and balance it out with the not so free energy, the real energy. Well, this is why physics has no jurisdiction, and I was able to get a couple guys at Stack Exchange. I don't think it was the physics department, I think it was the electrical engineering, to admit that free energy and reactance, electrical reactance, are one and the same thing. But then they would follow up with, well, but it's useless. Yet the job description of every electrical engineer is inclusive of one very important skill, and that is the ability to convert bidirectionally from reactive power to real power and from real power to reactive power. So they were lying by saying it's useless, or again, it's not relevant. Yeah, it's useless because it's lossless and thus doesn't come under thermodynamics of conversions and losses, but so what? Anyway, so conservation of energy has nothing to do with free energy, and thus no law of physics is broken because it is not even applicable. Free energy is electrical reactance, which means it's a force, it's not power. And it just so happens that electricity is made up of two forces that are not, do not come under the jurisdiction of the laws of physics. It's only when these two forces are combined to form electricity does the laws of physics kick in. Otherwise, they don't. We're dealing with fragments of electricity that are the ingredients of electricity, and those ingredients can be easily manipulated when they are not in union, when they are in so torn apart disunion as to say that the current of an oscillating circuit versus the phases of current versus the phases of voltage in an oscillating circuit are so far apart, so displaced from each other in terms of angular displacement of a cycle. You know, how we map the time frame of a cycle of oscillation. If the current versus the voltage, the two phases of both, are spread apart. The peaks are spread apart and the troughs are spread apart. All the parts of the wave are spread apart by 180 degrees, by 1/2 cycle. We don't even have normal capacitive reactance, which is a mere quarter cycle, or inductive reactance, another quarter cycle. In other words, inductive reactance is normally described as being lagging current by 90 degrees, a quarter cycle, whereas capacitive reactance is leading current by 90 degrees, a quarter cycle. Now, if you take these two quarter displacements and have them occur simultaneously, you now have 180 degrees displacement between them, and yet each are still fully in the realm of reactive power. They have nothing to do with real power. And yet the passive sign convention definition of a generator of power, any kind of power, is a displacement from the current and the voltage phases by 1/2 cycle. So here we have confirmation from passive sign convention that if we should produce current phases of oscillation versus the voltage phases of oscillation, spread eagle apart by 1/2 cycle between them, and each of them are a mere quarter cycle displacement from real power, from unity power factor, we now have the definition of the generation of electrical power in unlimited quantity. Literally, any amount of energy can be utilized, preferably something less than 10 volts at the maximum, but preferably around a millivolt or a microvolt, even better still, because it's the voltage that suppresses the reactance of, or the creation of free energy, the generation of free energy. And it's encouraged by our our transmission lines that are exclusively made of copper. There are 3 types of magnetism, and this is very important because magnetism is the one problem behind energy in general. There's no problem behind voltage. Anybody can create a circuit that'll amplify voltage. Look at any modern-day conventional Tesla coil, which is not the coil used by Tesla. He had a completely different design. But what we call a Tesla coil these days is a very easy way to boost voltage. Another example are the diode capacitor-based systems used to create ionic generators, like negative ion generators. Very often they'll boost up voltage using diodes and capacitors in a cascading manner, such that the boosted voltage will feed in to the next stage of the boost and keep getting boosted up in series. Well, that's easy, boosting voltage. That's because voltage has a tendency not to go anywhere and get lost. Especially in a copper-based system, it's very easy to transmit voltage across a copper transmission line, or copper wire in the coil of a motor, an electric motor in a Tesla Motors car for that matter. The problem is magnetism dissipates, and its corresponding current dissipates very rapidly. This was a problem they found in the telegraph cable transatlantic they were laying back in the 1800s, and it created garbled messages because the full power of electricity did not manage to get across the Atlantic Ocean. Only the voltage got across, and the magnetism fell behind, and by the time it caught up, the phases were so knocked out of alignment that they got a bunch of garbled noise. And after the course of about a week or two, the distortion got worse and worse until finally the magnetism didn't show up at all. The current component of electricity did not show up at all, only the voltage. Now, there are 2 ways you can solve this problem. You can retard the voltage using banks of capacitors every 100 miles to retard the phase of voltage so that it stays in alignment with the phases of current. Or you can preserve the phases of current from dissipating, conserve them against loss. And this latter was used by Oliver Heaviside to solve the problem, and the former is currently being used across the grid, across the United States, for example, when we have hundreds of miles, thousands of miles of transmission line. And if the phases should get out of alignment because of the speed of light factor, you'll have generators blowing up in various substations, and we don't want that to happen. The electrical utility grid people in charge do not want anything to happen that's out of balance, whether it's explosions on the one extreme or brownouts and blackouts on the opposite extreme. Okay, so let's go back to Oliver Heaviside. He recommended putting iron filings inside the insulation surrounding the copper core of the telegraph cable that was being laid down along the oceanic floor of the Atlantic Ocean. And it turns out there was a more efficient method to take a tape, a magnetic tape called permalloy, made out of a substance called permalloy, although I suspect VHS tape might do in a fix if you are hard to get a hold of permalloy. In any case, magnetic tape was wound around the bare copper core. Then a very thick insulation was applied on top of that. It turns out that a property of iron, of the ferromagnetism of iron, called magnetic remanence, has many instances. One very popular instance was the years between 1955 and 1975, when it was used in the computer core memory. You know, when you shut down your computer, you want some memory to be retained so that the operating system can remember how to operate when you turn the computer back on. You can't go to the hard drive right away. You have to go to the BIOS to get the information on how to start up the computer. And that has to be remembered somehow when you shut it off. Well, at the time, between those 2 years of 20 years, 2 decades, between 55 and 1975, they used magnetic remanence. They had little tiny microscopic ferrite rings that were capable of registering an impression left behind them of an orientation of polarization. So you have a coil or a copper wire magnetizing the ferrite ring to have a magnetic orientation going in one direction around the ferrite ring or the opposite direction, and which direction determined you would interpret it as being either a 1 or a 0 byte of information. And these little ferrite rings had a crisscrossing intersection of 2 copper wires going through, intersecting, and at that intersection point a ferrite ring was stationed around that intersection. And so they had a warp and a weave, literally a cloth of copper wires, and at every intersection of each warp and weave of a single copper wire was stationed a ferrite ring. And these things were so small you had to use a magnifying glass to assemble them or to even look at them. But each ferrite ring held 1 byte of information. It was either a 1 or a 0. And when the copper wires energized the ferrite ring, it was only needed to be for an instant. And then you don't apply any energy at all, and the magnetic, you literally created a footprint, a magnetic footprint called magnetic remanence that was retained in that ferrite ring in perpetuity. You know, Sir Isaac Newton's second law of motion, an object tends to stay in motion unless acted upon by another force of a different direction. Well, in the terms of magnetic remanence, it could be any direction, so long as you don't apply any new information in the form of energy oriented in any direction. It'll retain the memory of the prior recording. It literally records the orientation of energy that you applied, let's say a coil or the intersection of 2 copper wires. It'll retain that in perpetuity. It will never stop. And it's retained inside the ferrite ring in this case, in this example. It's not something you can measure on the outside, because if you try to measure it, you destroy it. It gets released, and it does release as energy, just like energy went in to become that magnetic memory. It does get released when you try to read off what that magnetic memory is. So we have used it for practical purposes. So magnetic remanence is not a big secret, and yet it's never really talked about, because iron, as an example, has this remarkable property to retain this magnetic footprint in perpetuity if never acted upon by another electrical force subsequent to the prior electrical force that put that impression into the iron in the first place. So iron has this property. So when permalloy, a type of iron alloy, was wrapped around the copper core, what it did was, when they applied voltage to the copper core transmission line, it generated a magnetic field, which did not drop off because the permalloy tape retained the memory of that magnetic field that the copper wire was generating when the voltage difference was applied to the copper core of the telegraph cable. And the permalloy tape was so efficient at retaining the magnetic field generated in close proximity to the exterior of that copper core that the magnetic field of the copper of the transmission line was managed to be retained throughout its entire length across the entire Atlantic Ocean. And now both phases of current and voltage arrived at its destination in phase, and you got perfect dots and dashes of a telegraph message sent across the Atlantic Ocean. So we know this system works, and yet today, in today's world, you don't see that system being used anymore. Why is that? Because, first of all, those are two properties of magnetism. Ferromagnetism, represented by the iron, and diamagnetism, represented by the copper. It turns out there's a third magnetic property that's very significant, and that's paramagnetism, represented by aluminum. Now, you'll find grounding wires running between the pole transformer outside our homes to the mains box of fuses on our mains panel inside our home. The grounding wire between the two will be aluminum, and it'll run along the two copper wires, the hot and the neutral, that runs between them. So you'll have three wires running between the pole transformer and the mains fuse box within the home. And that's specifically because aluminum does the opposite what iron does. Iron wants to concentrate that magnetic remnants, that magnetic memory inside itself. Meanwhile, aluminum wants to do the opposite. It wants to export it and get it out of itself. And so it'll do the opposite. It won't retain magnetic memory. It tries to get rid of it as fast as possible. And copper, it simply, dies out over a distance due to resistances of current. The current is resisted in copper wire, or any wire, but in copper, in this particular instance, copper. And so the magnetism dies off due to the resistance of the wire, the magnetic resistance. But aluminum, it just doesn't retain it at all. And probably for this reason, aluminum makes for great material in dishes and antenna that are shaped as a parabolic dish, because you can project an electromagnetic field to the dish and it'll bounce right off it, and if it's a parabolic arc that dish is shaped in the form of, it makes for a great, nice, tight magnetic beam coming out of that parabolic dish, because the aluminum doesn't want to have anything to do with magnetism. He wants to get rid of it. Now, diamagnetism is a funny word. So now we go to William Line, who spoke to Dort Jr. Dort Sr., his father, worked with the Germans on implementing Tesla's special generator in a small amount of the Germans' electro U-boats used by the Nazi Germans during World War II. These U-boats had the original or conventional means of recharging their battery bank, but they had to come to the surface to run the diesel-fired generators to recharge those batteries, and of course that makes them an easy target. But a small group of these electro U-boats had a second system, Plan B, that utilized Tesla's special generator, which the Germans did not get from Tesla by asking for it. They stole it from him during, or immediately before, I should say, his laboratory fire of 1895. He gave a demonstration at the World's Fair in Chicago in the Agricultural Building in 1893 to a small group of electrical engineers, one of whom wrote about it and published it in his book, The Writings and Inventions of Nikola Tesla, in 1894. So 1 year after the lecture, he put it in his book, the last chapter of his book, Tesla's Special Generator. And it ran on compressed air stored in liquid air tanks. In the following year after the publication of the book, and 2 years after the lecture in 1895, was the lab fire to hide the arson. It was arson to hide the theft. And we know this because one of the inventions having to do with the special generator was liquefaction of air in a very efficient manner to store this liquid air as the source for the decompression of that liquid air into highly pressurized air, not liquid air, but pressurized air, because it was steam or flash boiled, shall we say, to turn the liquid into a vapor. And then that compressed air ran the special generator. The special generator had a piston that was designed to operate like the reed in a wind instrument, such as an oboe or a clarinet, in which you can vary the pressure, but the oscillation of that reed is fixed. And the only way you're going to get different tones out of that type of wind instrument is a fingering. Whereas with a trumpet, you can purse your lips different ways. Or a flute, you can do different things when you blow the air across the mouthpiece. You don't just vary the pitch by your fingering on the air holes of that type of device. Well, with this type, it was a constant frequency because it was important to him, because this special generator was bolted to the floor of the electric U-boat so that it was magnetically coupled to the ferromagnetizable iron of the entire vessel. And this had something to do with increasing the horsepower, that factor alone. As William Line allegedly quotes Nikola Tesla as saying, for every 200 pounds of iron added to a special generator, 1 horsepower was increased as its output. So iron is very important for some reason in some of these devices, and it has something to do with magnetic remnants. But in the case of these U-boats, it gave them a minimum range of 30,000 miles, and they didn't have to come to the surface to recharge their batteries. They could stay under the surface because they just used the liquefied air that was boiled to create compressed air to run this piston and create the electricity needed to recharge the battery bank inside the electro U-boats. Well, Dort Sr. helped them implement this stolen technology. And we know it's stolen, I missed that point, because Karl Linde, Linde, of Germany, stole his liquefaction of air invention that he hadn't patented yet. They stole everything he had in his shop. Neutron bomb, levitational anti-gravity craft, all kinds of things that they worked on and developed in the course of the next half century to implement during World War II. And General Patton said if we had waited 3 weeks to invade Normandy, the war's outcome would have been very different, or the outcome of the invasion would have been very different, because the war would have gone on for many more years than it actually did. Because they had assembly lines buried in, subterranean or hidden in various places that were churning out things not fast enough, a whole realm of new technology that would have put them so far ahead of us that we would have taken decades to catch up with that new technology. They had a problem implementing their UFO technology or their anti-levitation or their levitational technology, because the electrostatic field that it created was so intense that if they put any dynamite on board, it immediately exploded and killed everybody on board and destroyed the craft. So they had to use it for other purposes, reconnaissance missions, for instance. They couldn't put armaments on board. So they had to develop beam weaponry, which Nikola Tesla did possess. So they stole a lot of things. In fact, the Tunguska affair in Siberia has been allegedly indicated to be a test case of Tesla's new beam weaponry that he was working on. Be that as it may, they had all this stuff they had to work on, and Dort Sr. was employed because Dort knew Tesla in some capacity. I think he was an apprentice or an assistant, and he was utilized by the Nazi Germans to help them develop their technology, in one case, his special generator. And Dort Jr. knew about this and relayed it to William Line, the quote that for every 200 pounds of iron added to Tesla's special generator, 1 horsepower was increased at its output. But he relayed another piece of information, that iron is the magnetic, copper is the active, and aluminum is reflective. Well, we've already covered two of those three items of interest, but but one of those three, copper is the active, doesn't make any sense unless we assume, oh yeah, that's the current or that's active. No, that's not it. What we call reactance in today's world, Dort Jr. was quoting his father as saying, Dort Sr. as saying that copper is the active. So we've changed the terminology, which helps to confuse the issue. And in turn, and as well as that, it turns out that reactance is a misnomer. It's partly true. If you apply energy to a coil or to a capacitor, you get a reactance coming out of it. But it's also true that the two components of electricity that make up electricity, the only two ingredients of electricity, just happen to be capacitive reactance and inductive reactance. But when they are totally in phase with each other, then we get real power. And all of this within a context of time. So we have three ingredients of electricity, two of them being materialistically spatial and one of them being temporal. And those three ingredients make electricity happen. Without all three in place working together, you don't have electricity, you have reactive power at the very least. You have a fragmentation of electricity into its component ingredients. And reactance is two-thirds of that. Two-thirds of electricity when it has been fragmented. And that's how you get free energy, is to manipulate electricity's components without manipulating electricity itself. Electricity is governed by the laws of physics and thermodynamics, so it's very difficult to manipulate it in any kind of gain, in any sense of gaining an advantage, an energy advantage, or advantage of any sort. But when you manipulate the ingredients of electricity as ingredients apart from each other, especially when they've been ripped apart by 180 degrees of angular phase difference between the phase of capacitive reactance versus the phase of inductive reactance, the capacitive being measured in voltage and the inductive being measured in amps. Now you get to manipulate them as individual factors, separated from each other distinctly enough that you can manipulate them with no regard whatsoever to the laws of physics getting in your way. Now, current, again, going back to the beginning of this little odyssey, current is the hardest thing to gain an advantage of. Yet the use of iron makes it easy. You just take magnetizable iron tape and wrap it around a copper core and insulate it, and you gain even greater efficiency if you snip a little bit of both ends of the coil or the transmission line of its tape, magnetic tape, so that it's just a normal copper core and then insulated, and you get an increase of efficiency. But you don't go beyond unity. The factor that's missing that takes us beyond unity and makes it an over-unity circuit is aluminum. The reason being its reflectivity. So you've got copper encouraging reactance, you've got iron retaining current, and then, when I say copper, I mean both inductive reactance and capacitive reactance, which the copper is only going to retain the capacitive reactance, while it's going to lose the inductive reactance very readily. So we bring in iron to retain the memory of that inductive reactance so that we can have current worth measuring. But now we bring in aluminum to create an echo, to reverberate, to bounce the current and the voltage off of that aluminum. Or let's put it this way. We've got the copper in the middle of a sandwich, busy reacting to the application of voltage. And then we have iron retaining it, retaining the magnetic field. We have the copper retaining the voltage field. And then we have the aluminum bouncing, particularly the magnetic, but also the voltage fields, both fields, back to where they came from, creating a reverb and an amplification thereby. So we don't just try to retain and conserve the two fields of electricity, the magnetic field and the electric field of a transmission line or of a coil of wire, but now we're trying to bounce it back towards the coil of wire or back towards the transmission line so that literally nothing escapes at all. Not just retention, but a complete internalization of the two reactances making up electricity. And that's Tesla's trimetal generator, a solid-state device that would last for thousands of years or hundreds of years and create over unity, literally a generator of power with no prime mover to speak of. You know, nothing like we think, oh, you got to turn a crank or something or burn a fuel like a nuclear reactor and create plutonium for nuclear warheads as a side effect. No, you don't have to deal with any of that. And just to give you an example of how useful the conversion of reactive power into real power can be, you can take a reactive heating element, such as a resistor, a resistive heating element, and convert reactance that has its current phase and its voltage phase out of phase with each other by 180 degrees and put it back together again and boil water to run a steam turbine to rotate an electric generator and do away with all nuclear power plants and the plutonium they create, and create free energy without any pollution. Well, especially no electric pollution if you keep it outside of city boundaries. But certainly no chemical or radioactive pollution at all. But anyway, that's a little off topic. So it's a little bullshit to say we need nuclear power for clean power. That's a lie. Reactance is all we need to create all the free power we want. And Nikola Tesla led the way by creating a generator that we don't know about, because during World War II, when knowledge of nuclear technology, Nazi technology, weaved its way back through the informational channels back to military intelligence of the United States and England, we began to get these hints, and so originally we thought Tesla was a crackpot up to that point, and now we had to take him seriously on an official public level. Well, very secret public level, high confidentiality public level. And so a large portion of the patents up to that point had to be sequestered and given military highly classified status and taken off of public access. And that's why we don't see many things that all we know of are stories, anecdotal stories, such as Tesla's trimetal generator, which one electrical engineer originally trained as a physicist, I won't embarrass him any further than I already have by naming his name, told me face to my face, that it's simply a rumor, Tesla's trimetal generator. It's just a rumor. Don't take it seriously. And I got so depressed immediately because I knew that was false. An electrician told me he met some guy who did replicate Tesla's trimetal generator and powered an electric motor with it, but told him nothing, him and his wife, nothing except that it involved the use of iron, copper, and aluminum, and left it at that, and he never saw that guy ever again, an associate electrician, a fellow electrician. And this was like 15, 20 years ago in the Midwest, somewhere in Kansas or Nebraska. Can't remember which. So that's a kind of a rundown of how we don't know about a lot of this stuff that's common knowledge, but we're told not to connect the dots. Don't look at the man behind the curtain. All due to free energy now is taken seriously, because this trimetal generator has two angles, depending on how you it has, depending on which way you tip the balance of scale, so to speak, on what it will produce. You can either have it produce power if you exemplify the iron aspect, but if you exemplify the aluminum aspect, it'll create anti-gravity and levitation, or its opposite, increased gravity, be able to submerge below the surface of the ocean, for instance. Because levitation or anti-gravity is really a question of buoyancy. It's not a question of levity. Because gravity and levity or anti-gravity is really a question of electrodynamics. And you can control it depending on how you engineer this device, which way you cause it to lean more heavily in the direction of. And so I prefer to stay in the direction of iron because I want power for an electric car, right? Or for a home, or for an appliance. And I don't want to have to use any more power than what powers crystal radio sets from 100 years ago, namely 1 microvolt. Because under simulation, that's the perfect amount. That's the amount of energy you and I produce, and trees and plants produce, and is the ambient background energy just above ground level. So a few feet off the ground, if you take a voltage difference, if it's only a few feet, it's about a microvolt. If you have a whip antenna about a meter long, to pick up on that. But if your whip antenna should be grounded to the earth and extend upwards to, say, 20 feet, that's what, 7 meters? Now you've got a voltage difference of a whole 500 millivolts, 1/2 of a volt. Already you have a difference, all by itself, with no added technique to increase it any further. Already you have 1/2 a volt. But if you want to ensure that you have unlimited voltage and amperage together, you have to put all of these pieces of the puzzle together and utilize them all at the same time in some kind of coordinated fashion. And that's what I suspect Tesla's trimetal generator did. It utilized the 3 properties of magnetism, the 3 primary properties, because we have 2 others I've learned recently about. Besides ferromagnetism, there's ferrimagnetism and anti-ferrimagnetism. But I don't concern myself too much with those because I don't think they're applicable, as I recall. Only ferromagnetism is applicable, and then diamagnetism, and then paramagnetism. Namely, magnetism, what we normally conventionally call ferromagnetism, and activity, and reflectivity. Those are the 3 properties of magnetism that we need to coordinate in order to get over unity out of a free energy device. Because voltage, like I say, is the easiest thing to build up because it's the hardest to lose. It's so easy to retain it and build it up and amplify it through various feedback techniques. But magnetism is a whole nother animal, and you need magnetism in conjunction with voltage in order to create electricity within a framework of time. You need all those 3 factors. It's not good enough to have voltage. Even though, technically, the power grid sells us voltage. They sell us a guarantee of 60 cycles of 120 volts or 240 volts, and then they charge us according to our kilowatt hours, but it's the voltage of 60 cycles that they deliver, or 50 cycles in Europe that they deliver. It's the voltage that's delivered. Now, let's go back a bit. If magnetism or current, the magnetism being the byproduct of current, or vice versa, the current the byproduct of magnetism, depending on how you want to look at it. Regardless, magnetism or current, the only reason why we have motors designed to be built to operate at certain voltages, and you have to stick with those voltages in order to operate the motor, the only reason why we have those voltage requirements for electric motors is because it's assumed when they build it, you got to build it with copper windings and that's it. And copper windings and an iron core and that's it. And the whole point is you're going to expect to have magnetic losses of a very large amount. And in order to compensate, you have to apply a certain specific voltage that motor was designed to accommodate in order to have the benefit of a certain level of current in order to operate at a certain wattage. But what if they're designed differently to retain a greater degree of their magnetism and thus not lose so much of their current, the power behind their current? Now they could operate at much lower voltages, so low that the units of voltage would be less than the units of current. In other words, you might be operating at 1 millivolt and be supplying 1,000 amperes of current to get what? 1 watt. But it would be such a difference in balance of voltage versus current that it'd be hardly any voltage at all required. I mean, you could easily use a AA battery, a 1.5 volt AA battery, to power a motor and get kiloamperes out of it instead of practically nothing. All because you designed it to run more efficiently using the various case-in-point factors that I've already enumerated in this recording. So there's so many different things that we stopped paying attention to after Oliver Heaviside and his solution to the telegraph problem, confronting people who were trying to lay down transatlantic telegraph cable in the 1800s, around the mid-1800s. Starting in the mid-1800s up until I think the 1880s, they were busy laying cable. Now they have removed all those cables that have that iron wrapping, and instead they have repeater stations every certain distance to boost the power. And I don't know how those repeater stations work, but they're we no longer have the Oliver Heaviside solution for somebody to go, oh, look at this, and then stumble across free energy. All you have to do is add aluminum, and now you've got over unity. You know, once you coordinate those three types of magnetism, you're going to have over unity. There's no question about it, because you've learned to fully integrate all the aspects of magnetism that have to be known in order to get over unity, not merely retain it, such as Oliver Heaviside was shooting for, but get more than the mere retention of magnetism and current, but to get more magnetism and current than you could possibly imagine, according to our conventional wisdom. And all of this being the case, that the energy applied to the circuit, you know, the old fascist idea that one unit of energy going into a circuit has to equal one unit of energy coming out. No, not if we forget about energy coming out and instead focus on the reactance coming out. Now, they don't equal each other because they're not even the same. It's like black people walking into a room and white people walking out. Sure, it's the same number of people entering versus exiting because you can only house or fit so many people inside that room, but you could have a different balance between how many black people versus how many white people. And oops, if the black people are reactive power and the white people are real power, you could have so much reactance going on in that room that, forget it, you're not going to have a stable population of black people anymore, because reactance can never maintain itself. Real power does, and that's this conservation of energy law is not a law; it's a description of the fact that energy cannot vary. Total overall energy can never vary; it's incapable of variance. But reactive power is incapable of continuity. It must change over time. It cannot stay the same. It either goes down or it goes up, but it never stays the same. It's complete opposite to real power. Real power must maintain itself overall if you count losses as well as what you utilize, as well as what goes in, and the losses and the benefits coming versus the losses and benefits coming out. But with reactance, it's the opposite. It must not equal. It cannot equal in versus out. And reactance happens all the time. We think it doesn't. But no, it does. Just take a simple piece of wire. You've got the surface area of that insulated magnetic winding wire giving us capacitive reactance, and you have the length of that wire giving us inductive reactance. So already a simple piece of wire gives us all electrical reactance right there. And this is the case even in a DC circuit. We have reactance taking place. So you can't get away from reactance. It's ubiquitous, I think is the term, ubiquitous. It's pandemic, if you want to consider it a problem. But if it's considered a benefit, then maybe we call it ubiquitous. But regardless, it's everywhere. It's all the time. We're always having reactance taking place. But we never encourage it, because it can be encouraged to such a degree that it has explosive power. So much so that it can rival any bomb you can imagine. In fact, I have already come to the conclusion that all of quantum physics can be described by electrodynamics if the full knowledge of electrodynamics was not kept from us. Now, it is taught to us, that's true, but we're told not to connect certain dots. That's the problem. Unless it's given that you have the responsibility to manage something like the electric utility grid, then you're taught all of the connections between all of the dots, and yet you have to keep secret or else you'll lose your job. While most electrical engineers are mere technicians, they're taught specific realms of electrodynamic theory, and they're taught it in such a way as to favor a limited awareness of the topic at hand. For instance, Ohm's law, current times voltage equals watts. That's a lie. Current, in actuality, does not exist. Current is a fiction. It's a shorthand mathematical substitution for something that's much more complicated that involves no current whatsoever. Instead, that current replaces voltage divided by impedance, and not any old voltage, but reactive voltage. And the other voltage that used to be used to multiply against current, that's applied voltage, which is static. So we have static voltage times reactive voltage divided by impedance equals total power, namely the reactive power plus the real power, namely apparent power. Only then do we have Ohm's law in its proper interpretation. But we're never taught it that way because, God forbid, technicians in the field should know the total picture, because they may start tinkering in their garage and come up with free energy devices if they were taught their topic, their subject, in a way that would encourage them to think on their own and draw their own conclusions. They're discouraged from thinking on their own. They're taught to be robots and repeat whatever they were told is true. That physics rules energy. Yeah, but it doesn't rule reactance. So, I've repeated a few points that are worth repeating, and I've gone over a lot of supporting points that are very worthwhile to know about. And I've given you a short little rundown on free energy. That it's not energy, but it is freely available reactive power. You can have any quantity of energy put in, and literally it won't matter. You'll still have the fixed amount of reactive power coming out. That's what's so bizarre about reactive power, if you formulate the circuit a certain way. And I've trained myself over 5 years to think like a simulator thinks, and recognize the policies that are written into the software of a simulator to hide the truth of how reactive power operates. I've managed to find those discrepancies and ignore them, and see the simulator in a light that in which electrodynamics should be seen in the light of. Namely, we can have all the power we want and never be a shortage, because the input doesn't matter. All that matters on the input is the signal. Whether it's a DC signal or an AC signal, doesn't matter. All that matters is the signal. And you can have any amount of wattage providing that signal. You can have microwatts, you can have nanowatts of power going in, but you can have any amount of power coming out within any time frame that you can imagine, whether it's nanoseconds or thousands or millions of seconds or anywhere in between. You can have just about any amount of power coming out and any amount of low power going in, provided it is low. That is one requirement. It has to be low power going in. You can have that kind of situation. So I thought it pertinent that you should know these things, because most people don't. I consider myself a layperson investigative journalist who picks topics, investigates them for a number of years to find out the scoop that nobody knows about, like the infinite range of golden ratios that I studied for 3 years, 20 years ago. These things should be investigated, and they should be shared with all of us. But most people couldn't care less. They just want to make a buck and provide for their family, and that is a problem. And school doesn't help. It dumbs us down. So there are all these factors, and the media lies, and the physicists lie, and the electrical engineers lie, And Eisenhower warned us against the military-industrial complex, which is, in one word, it's called fascism.